Okay, calculus is about three really big ideas. Those three big ideas are limits, derivatives, and integrals. So far, we've been talking about limits, and now we're going to tie limits to derivatives and share a little bit what that is. But the slope of a tangent line can be defined as a limit. Notice that when we first started this class, we started with one big question. What was that big question we started with at the beginning of class? Okay, 0 divided by 0, but Riker, what is the slope of a line at a given point on a curve when we only have 1 point? How do we do that? And so we are now going to define the slope of a line tangent as a limit. And here's how we do it. We just take a curve. We call it f of x. And we are going to define it at, in this case, we're going to call it point A. Anybody, what would we call the y value? L would be the limit. Another thing to call would be f of A. You did? I would like to know the slope of that tangent line. I need another point. So I'm going to choose another point. I'm going to call that point X. Same idea as P and Q. Same idea. What do we call this y value? F of X. What do we call that segment that I just drew? The secant line. You told me before that as Q approaches P, the slope of the secant line approaches the slope of the tangent line. Well, if I want to make the secant line approach the slope of the tangent line, what do I have to do? What do I have to move? Where do I have to move it? Move what closer to what? X closer to A. Would you agree? Okay. So right now, the slope of the secant line is f of x minus f of A divided by x minus A. Everybody agree that's the slope of the secant line? So now let's make it the tangent line. We just slap a limit in front of it. Limit as x goes to A. Let x approach A. And then we have the slope of the tangent line. That becomes our definition. We call it definition 1. There's another one that's really cool. I'll show you to you next unit. Let's see how we do this. Find an equation for line tangent to the function at the given point using definition 1. F of x is x squared minus 3, and the point is 1, negative 2. So if you think about this, this is a parabola. We're trying to find the slope of the line tangent at 1. Okay? So I have this definition. The limit as x approaches A. A is the x value that we're approaching. Anybody know the x value we're approaching? 1. Of f of x. What is f of x? X squared minus 3 minus f of A. That means what do we get when we plug 1 in? Get negative 2. So this is going to turn into plus 2 divided by x minus A. X minus 1. So therefore we have the limit as x goes to 1 of x squared minus 1 over x minus 1. Notice what happens if you plug 1 in. Get 0 over 0, right? We do not know that value. It's indeterminate. So therefore we remove the discontinuity. How do you remove this discontinuity? Factor x minus 1, x plus 1 over x minus 1. I can now plug in the x value that I'm approaching. And what do you get? Slope is 2. If you were asked to, would you be able to now write an equation for a tangent line? Yes. How could you check your answer if you wanted to? Graph the tangent line and the curve and make sure that they are the same. Piece of cake upside down. You've seen it before, right? Awesome. I want to be clear. Every single time you go through this process, you would get 0 over 0 And it ends up being, if you were to look at the curve, it ends up being that the limit exists and that there's a discontinuity that is removable. That happens every single time in these problems. Next one, you help me set it up. Limit what? X approaches 2 of 3x cubed minus 1 minus 23 all over. So limit as x goes to 2 of 3x cubed minus 24. Now what? Take out the 3, I get x cubed minus 8. X cubed minus 8 is a difference of cubes. That does factor. Limit as x goes to 2. 3 times x minus 2. What's the rest of it? X squared. 2x plus 4. We plug in 2. 2 squared is 4. Plus 4 is 8. Plus 4 is 12. Times 3. Turns out the slope of this guy is 36 at that spot. Following along? We good? You've already seen examples like A and B. We're going to move to C and D, and then you get started on your assignment. Limit as what? X approaches 6. Square root of x minus 2. Over. Uh-oh. Good old conjugate. When you don't know how to do the math, do the Spanish. Okay, I multiply by conjugate. What will I get in the numerator? Then I get x minus 6 times the quantity root of x minus 2 plus 2. Is that over there? Who is it? Is it Baller? Kleiner. Oh. Send somebody over there, check, make sure she's okay. What will happen? Nope. X minus 6 over x minus 6. I plug in 6 to the denominator here. 6 minus 2 is 4. Square root of 4 is 2. I get 1/4 is the slope. Top is x minus 6. Yep. Y minus y1 is equal to m times x minus x1. I know you guys know how to write equations for lines, correct? So I'm just saving us time by just finding the slope right now. We good? On the test, if I ask you to write the equation for a line, part of that is I want you to be able to verify your answer. Graph the function, graph the line, and they should be tangent. If they're not, you did something wrong, correct? Okay. All right, last one. Limit as x goes to 3 of again, I always think it's interesting. Every time you do this, you always get 0 over 0. Plug in that 3, you get 1 over 2 minus 1 over 2, which is 0 on the top. You get 0 on the bottom. It's always 0 over 0, which is an indeterminate value. We don't know what it is. There's a lot of things it could be. Here it came out to be 1/4. So we're going to determine that, and we're going to do a little bit of algebra. What do you think? You guys realize how smart you are? I mean, knowing to handle the algebra in this way, you're really quite elite mathematicians in this way. So good work. So now what am I going to get? Yep, distribute that negative. Very common mistake. Over. Over. As x goes to 3 of. It looks like I'm gonna write this as 3 minus x over 2 times x minus 1. I'm going to take Samantha's advice, multiply by the reciprocal, which is 1 over x minus 3. Draw out that negative, cancel off those terms. Now plug in 3. 3 minus 1 is 2, times 2 is 4. What do you think? Yep. So let's be clear about the small things that are happening. I'm going to let you guys work. You have this. Number one, you learn how to deal with rational expressions, radical expressions, and polynomials with this definition. You've also seen, and this is the big idea, you've learned why we've been talking about limits the whole time. The limits are what make this piece possible. And again, all these limit expressions, they are discontinuous, and we're filling that discontinuity. So it's pulling those pieces together. That's the last lesson for this unit. Here we go. Here we go.